In this video, we are going to take a look at infrastructure components and their role and impact on the network. This video will cover CCNA Objective 1.3, describe the impact of infrastructure components in an enterprise network. The discussion will include firewalls, access points, and wireless controllers. Our first component is the firewall. Firewalls are used to protect the network from threats and attacks by only allowing specific defined traffic through, and then filtering out all other traffic. A firewall can be a standalone device like a firewall server, or it can be a feature or service that's running on another device such as a router. Firewalls use various kinds of logic to decide if traffic should be allowed or blocked. And firewalls can identify traffic based on things like source and destination IP address, TCP and UDP ports, and even textual content in the Uniform Resource Identifier, or URI. Basically, a firewall can identify traffic based on anything that could be contained in either the header or the data field of a packet. Some firewalls are known as stateful firewalls. Stateful firewalls maintain state information about each packet, ensuring that only packets matching known active connections are allowed to pass through. For example, we could have a firewall that's configured to block or disallow all TCP traffic that's coming in from the internet. But we could have that firewall configured to allow TCP traffic to come in if that traffic was part of a connection that was initiated by a client on the inside of the firewall to a server on the outside. So in our example illustration here, the client on the inside network can make a TCP connection with the server, initiating that connection, and then TCP traffic that's part of that active connection could be allowed through the firewall. Some firewalls use security zones so that firewall rules can be applied to several interfaces at once when they're all configured to be part of the same zone. For example, in this illustration, if the zone inside, and that's the inside trusted network, say the local area network or the LAN, if that network is very large and may be consisting of 3 different interfaces on the firewall, zone rules can be applied to all 3 interfaces at once with a single set of configurations that's applied to the zone. And then every interface in that zone inherits those configurations. The purpose for this is to reduce administrative overhead and reduce the opportunity for configuration errors. A DMZ zone is where servers are placed if those servers need to be accessed by both internal users and by users on the internet. It's kind of an in-between zone between the trusted network on the inside and the untrusted network on the outside. And then, of course, there's an outside zone, which is the untrusted network, and an example of that would obviously be the internet. Now, most local area networks consist of wireless hosts as well as wired hosts. Wireless LANs, or WLANs, are used to connect wireless devices to the Ethernet LAN using radio waves as the medium. Sometimes you'll hear wireless LANs referred to as Wi-Fi. Wireless LAN standards are published by the IEEE under the 802.11 working group. Most home or small office, home office Wi-Fi environments use something called autonomous access points to connect the wireless hosts to the network. The autonomous access point is actually 3 devices all in one. They combine the functions of an Ethernet switch for the wired connections, a wireless access point for the wireless connections, and a router to route packets between the internal LAN and the WAN or the internet. Management of autonomous wireless access points is typically done through an administrative console that's accessed from a web browser from one of the hosts on the internal network. Autonomous access points are ideal for very small networks. Now, in large enterprise environments, the wireless network must span an enormous area and could be hundreds, thousands, or even tens of thousands of hosts, and it would be impractical to deploy hundreds or thousands of autonomous access points. Each of these autonomous access points would have to be separately managed and would have to advertise their own network. Instead, enterprise environments use a wireless LAN controller to centrally control and manage many lightweight access points, or LWAPs. The LWAPs forward data between the wired and wireless networks and are managed through something called a wireless LAN controller, using a protocol called Control and Provisioning of Wireless Access Points Protocol, or CAPWAP. So here you can see in this illustration, we have a very large enterprise network with many wireless hosts spread over a large area, and we have a lot of lightweight access points that are connecting those clients. And those lightweight access points are all managed together via the wireless or WLAN controller up at the top.